Hello students, today we are going to talk about congruency of triangles. I know so many of you who have encountered this congruency of triangles have felt it to be very confusing. And I'm telling you, it's the most easiest and most interesting of all topics in geometry according to me. So let's get started. Before I start the topic, let me remind you to subscribe to my channel and also put in comments whatever topic you want to learn so that I will be making videos of that. And you know the speciality of my videos is that I try to remove the misunderstanding that children have. So I'm not doing all the problems and I'm going to teach you how to solve any of that kind of problems. So that's a specialty. If you learn from me one problem, you can solve all the problems of that similar kind in your math subject, right? So let's get started. Don't forget to subscribe to my channel and click on the notifications button. And also, if you like this video, share it with your friends as well. So let's get to the topic. So, when we talk about congruency of triangles, so we have the four different postulates: SSS, SAS, ASA, and RHS. I'm just going to recap. What is SSS? SSS means it is side, side, side. Okay, side, side, side. SAS means side, angle, side. ASA means angle, side, angle. RHS means right angle, hypotenuse, and a side. I'm not going to explain all these things because there are textbooks and there are your teachers who explain all these things to you. I would just like to mention that for congruence of a triangle, at least three of the criterion has to be met. It can be three sides of a triangle is equal to other three sides of a triangle, okay, or it could be it could be a side, only one side, and one angle and another side. So, if such a scenario is there, then also two triangles are said to be congruent. The third one is if two angles are equal and one more side which is between them is equal, then also it is two triangles are congruent. Okay. For a right angle triangle, if we have two different right angles, if you have a right angle in both the triangles and if the hypotenuse is equal and one more side is equal, we know that those two triangles are congruent. You have to remember these three things, these four things, that's all. Rest is only your manipulation. So let's get to it. Okay, let's start with this. Most of the students have doubt which criterion to apply. You have to remember these four criterion: SSS, SAS, ASA, RHS. That's all. And the meaning of it. Now let's figure out this problem. In geometry, always you have to depend upon the diagram or the figure. Okay. And when you see here this, that means this side is equal to this side. So we have got one S. Then they also told this, they have mentioned like this. That means DE is equal to EC. So we have got one more S. Implicitly, they have not given us anything else. So for that, the foundations of geometry also is very much required. We see that two lines are intersecting. When two lines are intersecting, we know vertically opposite angles should be equal. So you should use the concept like vertically opposite angle, linear pair, complementary angles, these kind of things, concepts we should know. So here we are having vertically opposite angles. That means one more angle we have got. So clearly it is a SAS postulate is satisfied. Therefore, your triangle, these two triangles are congruent. Coming to the next figure. Now in this figure again, what they have given? If you see here, they have given angle. Okay, they have given an angle. Then they have also given one side. BC is equal to EF. That means they have given a this. Now, what are the postulates that is there? With A and S, that could be a SAS or ASA. Okay. In that, if you see, we have got a A, we have got a S. Can we find a side? We should see. Or again, we have got a A and we have got a S. We should see whether we have got a A. One more angle can we find? So in this figure, we don't have anything of a vertically opposite kind of a scenario, nor are we having any linear pair kind of scenario. But one more thing in the problem, actually, in the statement I have not written, they have mentioned one more hint, that is AE is equal to BD. They have given that as in the sentences of the question. That means this part is equal to this part. And that being said, we know we are talking about these two triangles. We are talking about these two triangles. So in these two triangles, one side we've already mentioned, the other side is AC and FD. There is no connection at all. So we will exclude that also. There is one connection here. This part in the AB, if this is the AB line, this is the AB line, and this is the ED line. AB is part of this triangle, ED is part of the top triangle. Now, in that, this part from here to here is common. Is common for both the triangles. When it is there in both the triangles, that is going to be equal. So what are we left with? We are left with AE and BD. That means in the bottom triangle, we have a common side, common part of the side, and one more part. This green, purely green part. Okay, purely green, purely red part and purely green part. If you see here, both these things are equal. So when you're adding a equal quantity to something equal, already this from this part to this part is equal. You're adding a equal quantity to this AE and you're adding the same equal quantity to BD. So thereby what is happening? We can say AB is equal to DE, we can say. That means from this hint that they have given us, we can say one more side is equal. That being said, now we could not find any angle equality, but we could find a sign. So it is side. So we can say it is a SAS postulate. We'll go to the next one. So let's say this is a figure. Okay. Okay. Let's say this is a figure. Now clearly all the measurements are also given. So what are they have given us? They have given us an angle. They have given us an angle. So it's an angle. They have given us one more angle. Okay. So they given us one more angle. And the thing is, they have not given us, oh, yeah, they have given us one more side as well. One more side. So they have given us. So surely it is a ASA postulate. But one thing you should always consider or see is this particular side should be between the two equal angles. We should make sure. That is why we call it as ASA. That's also a trick. This particular side is a common side that we're talking about, should be between the two angles mentioned. This side is surely not between the P and the X. Similarly, this side is not between the angle S and the U. So, do we say it is not congruent? Let's let's rethink again. If this is 110, this is 30, with angle sum property, we could say this is 140. That means surely this is going to be 40 degree. And similarly, this is going to be 40 degree. That being said, though they have given us these two angles, we should be considering angle V, angle R, angle V and angle R you should consider, and you should consider the angle P and the angle U. If you see here, 40, 110, 40, 110, between them is the 4 centimeter. That means we have got a side which is equal between the two equal angles. So, confirmly, it is a congruent triangle of the criteria ASA. Okay. Okay. So, then we'll go to the next one. Here all the centimeters are given. So, let's take this first figure. They have given, so we know that two triangles are there. This is the one triangle, this is another triangle. That being said, they have given one side from this triangle equal to one more side from this triangle, one side from this triangle equal to one more side from this triangle, and the third side is a common thing for both the triangles. So we have S, S, S. From the SSS postulate, this is a these two are congruent triangles. Let's come to this. Again, here also we have this side equal to this side and this side equal to this side. And the third side is a common side for both these two triangles, right? So here, even here, S, S, S is met. So these two triangles are also congruent. Coming to next, let's come to this. So in this, what have they given? This angle, you have to understand all these symbolic representations. This angle is equal to this angle. That means angle E is equal to angle B. Then they have given angle C is equal to angle F. Okay. Angle C is equal to angle F they have given. And the side that they have given is AB is equal to ED they have given. Now, as I explained to you, you have got an angle, and one more side also they have mentioned. But as I told you, you should always check for the side between the two angles. If E and F is the angle, the side between them is actually EF. And if the angle that they mentioned is C and B, the side is actually BC. But they have given us a different side. So, considering these two angles might be wrong. Okay. Considering these two angles might be wrong. So, what do? When these two angles are equal, we surely know that this angle will be equal to this angle. See, we cannot change the equality of the sides, but surely we can say the third angle is equal to the third angle of the two triangles. So now what happens? We should not be considering C and F. We should not be considering those angles. Instead, we should be considering angle A is equal to angle D. See, this angle is equal to this angle and angle B is equal to angle E. And the side is between them. Surely this is a ASA postulate now and it is surely meeting the criteria of congruence. Now let's look at this. Okay. In this, what they have given us is they have given us that this angle is equal to this angle and this side is equal to this side, and also they have mentioned this side is equal to this side. Now, because they have given us only one angle, we can't predict anything about the other two angles. Say, for example, if this was 30 degree, this also will be 30 degree. But this, the other two can, how much will be 130, right? 130, so 150. 150 means it can be 70 and 80, 70 and 80, or it could be 110 and 40. We never know. We can't predict that. We can't predict that. So we can't tell about anything about the other two angles. So because they have given us two sides and an angle, we should again check. We should check whether our two sides are given and an angle is given. Again, here also this angle should be between the two sides given to us. Which is the angle which is between the two sides given here? It is angle O. It is angle O. And here in this case, it's angle C. Our problem is they have not given the equality for these two angles. Thereby, we cannot say whether this is congruent or not. We cannot say. It is not that it's not possible, but we cannot confirm. So, in geometry, whichever we cannot confirm, we just say it's not possible to find out. Yeah, answers are possible that you can say mathematics sometimes. It's not always having answers. Sometimes there are no answers as well. Okay, so I hope this is clear to you all. The next thing, let's take one last complex problem and figure out whether we can find out the congruency of that. Just by looking at the triangle, just by looking at the figure, what are we seeing? We are seeing one angle equality, another angle equality. Here, if you see, this angle is equal to this angle. So another angle equality is there, and one more side equality is there, right? So, and that particular side is between those two angles. Is it between those two angles? Of course. See here, this side is between these two angles and BC is between these two angles. So clearly it is ASA postulate. Now, many students get confused now. First of all, what triangles to consider because it's a complex figure. See, basically these three of both all the three things, let it be the angle and sides, are part of two set of triangles. Two set of triangles I'll mention here. It could be these two triangles, or it could also be this triangle and this triangle. If you see here, these two angles and these two side, this one side is part of both these triangle figures. So, if you're being asked a question of what, you could be asked about the DCB triangle and AEC. Those are also congruent because of the same ASA. Or it could be, if I mention this as M and N, you can also say that AMC and CNB, these two are also congruent. Did you notice that even the previously drawn blue triangles, as well as now drawn eight red triangles, both of them, both the sets are having the same angles and the same side equal. So there are two sets of congruent triangles in this particular figure. So try to see the triangles as separate entities. You have to practice that. Okay, then you will be able to figure out the congruencies. Just to recap, you have to take up whatever is given to you first. My usual problem solving steps. What is given to you first? Note it down. And what do you have to find? Obviously, congruency. For that, if certain criteria is already given, angle is given, you know that you have to find one more side for the congruency. Try to see if you can find a side which is equal. Or if they're given two sides, check whether you can find a side, one more side, or check whether if you can find one more angle which is equal. Okay, if it's a right angle triangle, you will have to see you should see right angle means two different right angles, 90 degrees there. You have to see whether the hypotenuse is equal and one more side is equal. So whatever is given, list it down, then think what you have to find, and find, if based on what you find, figure out which postulate will apply to this congruence criteria. I hope all your doubts are clarified. If not, visit this video again and share this video. Without fail, subscribe to my channel so that you keep getting updates. Please click on the bell icon as well. See you with the next video based on students' request. Until then, bye bye from Kala, the Thinking Catalyst.